So we're on page 29. This is the last part. It says working with the intermediate value theorem. Wow, there's a lot of words for something that I think you will really pick up on easily. If the temperature was 62 degrees this morning, and then it's 85 degrees by 2 p.m., did it have to be 80 degrees at some point?
Yeah.
Yes. That right there is the intermediate value theorem. To go from 62 to 85, did I have to pass through 80 at least once? Yes. That's this IVT. You can always use IVT as some shorthand. Biscuit sound for the shorthand, okay? So, yes, we're going to say, yeah. Okay, what about, did it have to be 90 degrees at some point? Could it have been? It could have been, but it didn't have to be, okay? If I am driving to Penn State and I got clocked going 90 miles an hour, did I have to be going 30 miles an hour at some point on my drive?
Yes.
Yeah, because what's my car going to start at? I can't be getting in the running car. That is not safe. So if I started at 0, I got clocked at 90. Not really. I'm not driving 90. I had to be going 30 at some point. Did I have to be going 92 at some point?
No.
No, I didn't have to be. Could I have been?
Yes.
Yes. So now here it comes mathematically. It says the intermediate value theorem definition. A function, y equals f of x, that is continuous. It has to be continuous. Just like my accelerator on my car. It's going to continuously grow. I'm not going to skip miles per hour because I've got my new car. My old car, maybe. And if it's continuous, so it has no holes, no jumps, no infinite discontinuities, it must take on every value between f of a and f of b. Draw a picture and explain this. Okay, so if I were you guys, let's go ahead and draw this. I've got some function like this, woo! And I'm going to say it goes from a to b. Boop to boop. Is what I just drew continuous?
Yes.
Yeah, and it said continuous from a to b. And it includes a and b because they put brackets here and I put closed holes there. Okay. Then it must take on every value between f of a and f of b. So if this is the point a, this is technically the point a, f of a, because f of a is just fancy for y, and this is the point b, f of b. So my y value down here, we're going to call f of a, and my y value up here, we're going to call f of b. So it says, do you guys want to put an actual value here? What do we want to say our lowest y value is here? We're just making up a number. Negative. Let's go a little further. -1's fine. Actually, I'm fine with it. What are we putting up here?
3.
Sure. Okay. So let's go put this in some terms that might help us. I'm going to say if there is a function whose y values at its endpoints are, as Lobley said, -1 and 3. Thank you, Mark. Then y must also equal everything in between, you guys. So if we were at -1, we might say -0.9, -0.5, 0, 1, 2, etc. And every number in between. It's a lot to write. Okay, let's take a peek at this then. Let's put this, here we go. H is this function. Can the intermediate value theorem be applied to guarantee a value within this interval where the function equals 0? So here's my question. First of all, x cubed, what's an x cubed graph going to look like? Boom, is that continuous? So an x cubed graph continuous? Yes. There's nothing here to make us believe that it'd be discontinuous, like a piecewise function. Okay, so this is continuous. That has to be true for the intermediate value theorem to be applied. And it says just from 1 to 5. Does my y value have to cross through 0 at just between 1 and 5? Okay, it's because I love you. What are we going to plug in?
Plug in
So,
value for 1.
Yeah, we want to go find, you guys. I want you to write it like this. H of 1. And that means we got 1 cubed minus 2 times 1 squared minus 4 times 1 minus 5. Now, we don't need a calculator for that. That's ridiculous. You know what we do need it for when we plug in 5? What's this one going to get me? 1 minus 2, minus 4, minus 5?
1 minus 4 minus 4 minus 5.
What'd you get? Negative. I'll wait. Negative 10. Thanks. So h of 1 is negative 10. At the one endpoint, when x is 1, my y is negative 10. At the other endpoint, h of 5. Yeah, you're right. AP is not even going to make you plug that in by hand. When I plug in a 5 there, what's 5 cubed minus 2 times 5 squared, blah, blah, blah. What'd y'all get? On the left endpoint, maybe a little picture would help you. We're at 1, negative 10. At the right endpoint, my axes are not going to be right, but I'm just going to write it as 550. This graph, I don't know what it looks like. Who cares? Did we have to cross through 0 at some point? To go from negative 10 to 50, do you have to pass through 0? 100%. So we're going to say, yeah. Now, it's important to say the specifications. This is where that free response part is going to get you points from AP. We've got to say, because h of x is continuous, on, and they gave us that interval, 1 to 5. That's like a requirement. In intermediate value theorem, it can't even be applied unless we know that the function's continuous. And how are we going to say this? That 0 fits between these two. We're literally going to say h of 1 is less than or equal to 0, which is less than or equal to h of 5. And that's just saying negative 10 is less than 0, which is less than 50. And maybe Tatum would write it that way. Tatum, you could say negative 10 is less than or equal to 0, which is less than or equal to 50. If this notation, you guys, oopsies. Oh, gosh. Come on. If this notation you're uncomfortable with, we'll get more comfortable as the year goes through. This is okay, too. So we're going to say because the function is continuous and negative 10 is less than 0, which is less than 50, the intermediate value theorem applies. Can you abbreviate IVT? Heck yes. All right, you guys, selected values of the continuous function are given. I only gave you points on this graph. I didn't give you the actual function. But look what they said. It's continuous. Okay, they gave us that requirement. Check. What is the fewest number of zeros we can have on the interval from 20 to 30? Those are my endpoints. Zeros are where we cross the y-axis, that my y value is 0. F of x is just fancy for 0. Any ideas?
2.
Ooh, how'd you know that?
Because as it starts out negative, then becomes positive.
Wait, where? Where's it negative?
It starts positive and drops. And then
Right.
It goes back positive.
To go from 1 to negative 3, wouldn't we have to cross through 0 somewhere?
Yes.
Okay? And then from
Negative 3 to 1.
negative
That's
3
0 again.
to 1, I'd have to cross through 0 again at some point. Could I nail down where? No. But is it guaranteed to go from a negative number to a positive number? I got to go through 0. Yeah. Could it have happened more than twice? We don't know. We don't know any more info. But what's the minimum? 2 times. Okay. Oh, wait. We didn't even pick an answer. Which one is it? C. Okay. This next one, definitely calculator active. Tank is leaking water. The amount of water in the tank is modeled by this madness. Plus 500. Don't forget about that plus 500. Between 0 and 60. Oh, and look what word they also gave us. It's continuous. It's necessary. Can the intermediate value theorem be applied to guarantee that there's a time in the first hour, 0 to 60 minutes, that makes sense on that interval, that the tank contains 100 gallons? What do we got to do first? Plug in 0. Let's go find W of 0. You guys, I'm going to teach you a shortcut on your calculator. Everybody grab your calculator. Go to the home screen. Everybody go type in 0, stow, x, enter. 0, stow is on the left-hand side, S-T-O. 0, stow, x, enter. Now I want us to go all write that equation. 500 over 1 plus 4d e to the negative 0.1. They have t. I'm just going to put an x. And then don't forget to get out of that fraction and say plus 500. Okay, no worries. So did you guys get 512? what?
195.
Nice. Marek, you remember we have to go 3 decimals. That's huge, Marek. That's great. Guys, we have to write 3 decimals or they won't give you a point. We okay with that? Now, the reason I had you store something, I want you to find W of 60. So you guys, now I want you to go 60, stow, X, enter. 60, stow, X, enter. Now I'm going to just go up and highlight that crazy equation that I wrote, hit enter twice, and it's going to plug in 60 for us. 954.897. Thank you for the 3 decimals. Okay, so we're saying at the beginning, this tank already had 512 gallons in it. After an hour, it had 954 gallons in it. So we're under the impression that this tank is filling up. It says at any point in the first hour, is it guaranteed that there's a time that there were 100 gallons in it? No. So we're going to say no. And then I'd say W of 0 is not less than or equal to 100, which is not less than or equal to 954 point. Oh, I shouldn't do that. I'm doing 2 different versions. Instead of 954.897, I'd just say W of 60.
I feel like instead of messing around with the X values, you could just do a graph.
That's an idea too. Yeah, the window I think would be annoying though on the graph. Yeah. So you guys, I'm going to throw a symbol in there for you. Does anyone remember what this means? Doot, doot, doot. Therefore, Bob was paying attention, guys. The 3 dots in a triangle, you use this in college math a lot. It means therefore. Since the smallest at the first interval and the end of the interval, they're not, 100's not in between them. Therefore, the intermediate value theorem does not apply. A W28 value? 66. I got a 24, but am I wrong?
Yeah, I got
66. Thanks. 66 point what? 193. Okay. Yeah. So it says, which of the following guarantees a solution between 24 and 28? What Y falls in between those two? Agreed. Boom. Let's just talk through this real fast, and then we'll have time for a little homework and be done with it. It says, hey, the number of fish in a pond at time t years is modeled by that function. It is continuous. F is continuous. Notice these words that we're noticing now. Such that F of 0 is 80. What do you think that means? At 0 hours or at the beginning, 80 fish in the pond. Very good. How about as t goes to infinity? Explain the meaning as the limit as t goes to infinity. As time goes on forever, what are they actually asking for? Horizontal asymptote. And which one do you think we'd need to look for as t is approaching infinity? The first one, second one, bigger than 8. Everything bigger than 8. We're getting bigger here.
So are they asking about like a carrying capacity, basically?
Basically, what will the pond max out at, right? We can't keep having more fish because there's not going to be enough food and things for these fishies. Okay, so what do we think? We're looking at the limit as t approaches infinity of 200 plus 80t over 2 plus 0.05t without a calculator. What? He's like, yeah, he's saying, I just need to look at the things with the biggest exponent. Oh, yeah. What's that going to be? Yeah, because think about this, you guys. If it was 80 divided by a half, which would be 0.5, it'd be the same as 80 times 2, which is 160. So since that decimal is moved over, we're going to make it 1,600. And bless you, what would we say? As time increases, we can't really say it goes to infinity, but as time goes on, the number of fish in the pond approaches how much? Yeah. And then it says, is the function n continuous? It says f is continuous, but it didn't say about n. N is all of these crazy things. Is it continuous at t equals 8? What do we have to compare? Yeah, we just have to compare where that 8 break is happening, and that's potentially here and here. So how would I do that? We're going to say, okay. We're going to say, all right, we got to go find what is the limit as t approaches 8. From the left side, I'm going to say is that top function, 25t plus 150. And when I plug in an 8 there, it's 25 times 8. If I had 8 quarters, how much do you have? Yeah, $2 plus 150 is 350. So as I'm approaching it from the left side, I get 350. What about as I'm approaching 8 from the positive side? I'm going to put that in cute pink. Limit as t approaches 8 from the positive side of 200 plus 80t over 2 plus 0.05t. You can use a calculator, go for it. What'd y'all get? Did we get 350 again? That's convenient. So as I approach t from the left and the right, and as t is 8, is that also 350? We get to say yes because t is 8 at that exact same equation. So we're going to say continuous or discontinuous? Continuous. So we're going to say n is continuous at t equals 8 because we're going to say the limit, whoa, go down, because the limit as t approaches 8 of n of t is equal to n of 8. Okay, so last thing, it says the function n is continuous at t equals 6. Is there a time between 0 and 6 where the function's value is 250? So, justify your answer. Notice that they said, hey, the function is continuous. What theorem are they asking us to apply?
IVT.
Intermediate value theorem. Very good. Is there a time between 0 and 6? So these are my endpoints. I want to go compare n of 0 and n of 6. N of 0. Any ideas if I plug in 0 here? Oh, I don't even have a function. They gave us the info somewhere, though. Keep reading.
0 equals 80.
Yeah, they do that to us. This is called the stem of the question. Sometimes you got to dig for that piece of info. So you're like, oh my gosh, what? So maybe draw yourself a little arrow and be like, oh, I wouldn't have seen that. N of 0 is 80. N of 6, where am I plugging in 6? The middle one, right? 6 times 25 plus 150. 300. What do we think? Does the intermediate value theorem apply? Will we cross through 250? Yeah, and how are we going to say that? We're going to say yes, because n is continuous. Very good. We do need to specify n is continuous on what? We got to say from 0 to 6. You could put it that way, or you could write it just how they did. So maybe we'll just do it how they did it, so because you can always just copy how they write things. So we can say 0 is less than or equal to t is less than or equal to 6. And we know n of 0 is less than or equal to 250, which is less than or equal to n of 6. Therefore, the intermediate value theorem applies. So there were 2 requirements to get the 2 points for this, stating that my function was continuous and the intervals.